Hello, hello, hello. Back at it with the Arduino. Back at it with the Arduino. Arduino, Arduino. It's been a while, chat. I know it's definitely been a while since I've last streamed. Been kind of busy. Low-key been procrastinating, that's why. But back at it again.
Series and parallel circuits. You just built a simple circuit composed of an Arduino Uno R3/R4 board, a resistor, and an LED. These components were connected in a single path, allowing current to flow from the board, through the resistor, through the LED, and back to the battery.
Hmm. I've already learned about series and
However,
parallel in
most circuits are
my
not quite
classes,
so
so.
simple. Components in a circuit can be wired in one of two ways, series or parallel. In a series circuit, the components are wired one after the other, forming a single path for current to flow through. The circuit you just wired is a series circuit. In a parallel circuit, components are wired in such a way that there are multiple paths for electricity to flow through. However, most circuits are not quite so simple. Components in a circuit can be wired in one of two ways, series or parallel. In a series circuit, the components are wired one after the other, forming a single path for current to flow through. The circuit you just wired is a series circuit. In a parallel circuit, components are wired in such a way that there are multiple paths for electricity to flow through.
In this activity, you'll create it. Ooh. In this activity, you'll create a series circuit with multiple LEDs. I call that a series circuit. Ba 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 ba. It's stuck in my head, guys. Ah, I need my multimeter still. Loki, the multimeter has been my bane. You'll never take me home. Oh shoot, I forgot to get the 220 is the blue one. Gotta confirm. Yep. I look, you could just build the circuit like this. Mm. 8 to 10. For the 8. And then bend this a little bit. Bang, circuit done. Shush, fish, head, head, hoot, head, head, ho. Head, 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 ho. Head, head, ho. Head, 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 ho. Head, 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 ho. Head, 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 ho. I look want to do more with this channel, other than just projects and coding and doing all that. So, like, I want to do that, yes, but I also low-key want to uh do any of my other hobbies, not only just work. Look at your circuit. Yeah. positive to pin 13. Ground. Which ground is it connected to? The first one. Continue the blank program. 3-second intervals. Time to plug it in. 3, 2, 1. Oh yeah. One, two, three. 1, 2, 3. Yeah. Like while it's still powered on. Alright. I moved from pin 13. SV. So I could unplug this. So SV makes it stay on. Oops. What happened? Oh, there's no power to the Arduino board, of course. Of course it stayed off. Attach the long jumper wire connected to the positive terminal of the breadboard's 5V pin on. Stay on the. Oh, that says 5V, not SV. Loki, I thought that said SV. It does say 5V, then there's 3.3V, there's a reset. Analog in. Okay. Pin provides a constant 5 volts of DC electricity to the circuit. This is different from pin 13, which can be programmed to turn on and off the board. Okay, pin 13 can be programmed.
You now have a series circuit with 2 LEDs. Follow the current through the circuit. From the 5V pin on the Arduino Uno R3/R4 board, the current runs through the long jumper wire to the positive terminal of the breadboard.
Yep.
It then enters the 220 ohm resistor, where it meets resistance, reducing the amount of current. Without this resistor, the current flowing through the LEDs would be too great and the LEDs would burn out. From the resistor, the current flows through the first LED, which lights up due to the current. From the first LED, the current flows through the short jumper wire to the second LED, which also lights up. After the current leaves the second LED, it flows back to the negative terminal of the breadboard. It then flows back to the ground pin of the Arduino Uno R3/R4 board to complete the circuit.
Yes. Test and modify.
Test and modify. In this activity, you'll experiment with your series circuit. Make sure to have your engineering notebook handy for this activity. 1. With the circuit complete, remove one of the LEDs. Notice what happens to the other LED. Replace the LED to complete the circuit again. Remove the other LED. Again, notice what happens to the circuit.
They both turn off.
Replace the LED once again to complete the circuit.
Yeah.
In a series circuit, what happens when you remove one of the components? Why? Record
It
your response in your
turns off.
engineering notebook in the series circuit section of Lesson 2.
Too easy, bro.
2. Turn the multimeter to the 20 VDC setting. 3. With the 2 LED circuit lit, use the multimeter to measure the voltage across the resistor. Touch the red test lead to the resistor wire connected to the positive terminal of the breadboard. Touch the black test lead to the resistor wire near LED 1. Record the resistor voltage in the tables row for the 2 LED circuit.
Bro, this shit is melting. Like, melting. Or not. This is actually melting. It's actually getting melted hard. How did it melt again? Like, what's melting it? Like, did it? It's actually melted again. What the heck? Why does it melt? What's causing it to melt? I'm actually confused. Yeah, it's actually just stuck again. What is causing this to melt? Yeah. This multimeter's on the fritz. No, not on the fritz, but like it's melting for no reason. Doesn't even get that hot right where I am. At least like not hot enough to melt it constantly. Well, this is ready. I just need to answer this first though. In a series circuit, what happens when you remove one of the components? In a series circuit, when you remove one of the components, open, right? Yeah. Why? Circuit. Wait. Okay. One point two four. Yeah, 1.24.
Note, when you measure the voltage being used by a component in a circuit, it is often called measuring the voltage across that component. Remember that voltage is a difference in electrical energy between 2 points in a circuit. When you measure the voltage used by a component, you're measuring the difference in electrical energy from one side to the other side of the component.
It's the difference between one side to the other side. Measure the voltage across one LED.
4. Measure the voltage across LED 1 in the circuit. Touch the red test lead to the anode of the LED. Touch the black test lead to the cathode of the LED. Record the voltage across LED 1 in the tables row for the 2 LED circuit.
1.8? Yeah, 1.8. 1.80. 1.80V.
Five. Measure the voltage across LED 2 in the circuit. Touch the red test lead to the anode of the LED. Touch the black test lead to the cathode of the LED.
Same thing, 1.8.
Record the voltage across LED 2 in the tables row for the 2 LED circuit. Six. For the 2 LED circuit, add up the resistor voltage, LED 1 voltage, and LED 2 voltage. Record the sum in the total voltage column of the table.
180 plus 180. 6. 16. 3.6. 3.6, right? 3.6, so it'd be 4.84? 4.84? Yep. 4.84. And it wants me to add another. Fourteen, 16. and then 16. Why is it so dim? Like, that's bright. That's like pretty bright for two. If I only do one, is it brighter? That makes sense, no? It's so dim. Like, you could barely see it on camera. Oh, you could see it on camera of, like, good. But, like, oh my goodness. So many fuck. Okay. Like, you could see it on camera good, but, like, in real life, this is so, like, dim that you could see it on camera. Like, it looks fine on camera, but it's hella dim in real life. Six. It's actually just 0.06 for 3 LED. 0.06 volts. 0.59. 1.6, bro. 1.60 volts. And then it should be the same for the other two. 1.6, 1.6. Fine. This one is 1.59. So it's 4.85 V. So they're like about the same. What happened? How is the brightness of the more LEDs you add, the dimmer the LEDs are? This makes sense because the same voltage is spread through throughout circuit. Same voltage is spread throughout the circuit. No matter the okay. Voltage is spread throughout the circuit no matter the number of components. So when there are so when there are more LEDs, the Okay. Remove all components from your circuit board. Unplug. Is it negative first? Look, I forgot. So it's negative first. Might as well do parallel now. I have. What time is it? I have time. I could do parallel. I need to move the camera a little bit more back because I still have a good chunk of space here where I actually do this stuff. So the camera doesn't really pick up what I'm doing. But I don't want to fix it now because I don't want to. My room's kind of messy. I could build this right now. I need two of those. I need three. I think that's all I need. I think I have everything else. Let me build the circuit real quick. Don't need this third one. Four. Do another one. It's on 8 and 12. 10. 8 and 10. Man, this screw's loose. Ten to ground. Okay, there we go. This is parallel. I already created this circuit. I created the circuit even before. To show the different resistors, I remember. Now let me plug it in. Boom.
Both LEDs should now be lit. This circuit represents two LEDs in a parallel circuit. There are two paths for the current to flow through.
Mm-hmm.
Follow the current through the circuit. From the 5V pin on the Arduino Uno R3/R4 board, the current flows to the positive terminal of the breadboard through the red power lead. From here, the circuit splits into two paths. In the first path, the current enters the first resistor, where the current is reduced to an amount the LED can safely manage. From the resistor, the current flows through the first LED and then through the jumper wire to the negative terminal of the breadboard. In the second path, the current enters the second resistor, where the current is reduced. The current then flows through the second LED and then through the jumper wire to the negative terminal of the breadboard. At the negative terminal, the two paths join back together and the current then flows through the black power lead to the ground pin of the Arduino Uno R3/R4 board.
Well, I know if you remove one, it doesn't break the circuit because it's basically two different circuits that are powered by the same thing. Yeah, it doesn't break the circuit. If you break one, it doesn't break the other because they're running parallel to each other. They're not, they're basically two, yeah, like I said, they're basically two different circuits running on the same power source. So if the power source goes away, they both go away. But if you remove one LED, the other LED is still fine because they are not directly connected to each other.
Test and modify. In this activity, you'll experiment with your parallel circuit. Make sure to have your engineering notebook handy for this activity. 1. With the circuit complete, remove one of the LEDs.
I already did that.
Notice what happens to the other LED. Replace the LED. Remove the other LED. Again, notice what happens to the circuit. Replace the LED. In a parallel circuit, what happens when you remove one of the components? Why? Record your response in your engineering notebook in the parallel circuit section of Lesson 2.
In a parallel circuit, if you remove one branch, it breaks only that branch. But the other one stays the same. So if you remove one LED, the other LED is still on. This is because just did to the okay. VDC 20.
Two. Turn the multimeter to the 20 VDC setting. 3. In a parallel circuit, each branch of the circuit gets the full voltage being supplied by the source. That means in your circuit, each branch should receive about 5 volts of electricity. You can test this with your multimeter. In the first path, touch the red test lead to the resistor wire connected to the positive terminal of the breadboard. Touch the black test lead to the metal part of the jumper wire where it enters the negative terminal of the breadboard.
4.82.
The multimeter should read about 5 volts.
Yeah, 4.82. Yeah, 4.82. Second volt, it should be about 5 volts. Yeah, they're both the same.
Five. If each path of the circuit gets the full 5 volts from the Arduino Uno R3/R4 board, what does that mean for the LEDs that are wired in parallel? With the 2 LED circuit lit, use the multimeter to measure the voltage across the first LED in the circuit. Touch the red test lead to the anode of the LED. Touch the black test lead to the cathode.
1.94. 1.92. Interesting. Okay. They're about the same. They're only a point 0.2 off. 1.94. Measure the Yeah? 1.92. Third. Bro, it fell on the floor. Oh my goodness. Where'd it go? This small wire, bro. Of course, a small wire falls on the floor. Where'd it go? Oh my goodness. It's just gone. It's so small that it's just gone. It's just gone. It fell here and then I drop. It should just drop straight down. Damn it. Oh, there it is. I gotta finish this real quick. 14. This goes from 14 to 16. And then this goes from 16 to the ground. To the ground. There we go. Now 3 are lit up. Okay, now they should still be around 1.9. This is at 1.95 now. Plus minus or 1.94. This is switching between 4 and 5. 1.92. 1.92. I'll just put the same. 1.94 V. 1.92 V. 1.92 V.
Nine. What happens to the brightness of the LEDs as you add more LEDs wired in parallel to the circuit?
They stay the same.
Record your response in your engineering notebook. In a parallel circuit, each path gets the full voltage supplied by the power source. Because each path in your circuit has the same components, they should have similar behaviors. Any differences in voltage or behavior between LED 1, 2, and 3 is due to small manufacturing differences in the LEDs and resistors.
That makes sense.
10. Compare the LED voltages for the 2 LED and 3 LED circuits. Based on your data, how many LED paths do you think you could add to the circuit and have them all remain lit? Why do you think this? Record your response in your engineering notebook. 11. Remove all components from your circuit board. Unplug the USB cable from the Arduino Uno R3/R4 board. Store all components in their proper storage location.
Yep. How many LEDs paths do you think you could add? I'm guessing you could add like an infinite amount. The only limitation is how big of a breadboard you have. Because the voltage stays the same, nothing really happens except for the manufacturing differences. So, basically an infinite amount. And or well, near infinite. Paths. D. Ports. This is because amount of yep, that's good enough. Okay, well, I think that's it for me today. That was pretty fun. Well, I can do that later. Well, that's goodbye for now. Uh, thank you, thank you guys for whoever's watching the stream. Thank you guys for watching. Um, hopefully I'll stream tomorrow, but there is something happening tomorrow. It's a special day. T one It's a special day tomorrow. Not for me, but for someone else. So, um, maybe not. I'll stream tomorrow. So it's still up for debate, depending on if there's something we're doing or whatnot. So I'll see you guys later. Um, if I see you tomorrow, I'll see you tomorrow. Hopefully I can stream tomorrow, but if not, then I'll just stream on Tuesday. So, all right. I'll see you guys.